Yeah. If a buffer is created with HA and A at 0.3 molars each, where the pK of HA is 8 and the pH of the buffered solution is 8, and then 0.10 moles of HNO3 are added to the solution, what is the resulting pH? For this problem, the formula we'll need to use is pH equals pKa plus log of conjugated base over the acid. The first thing that we know from this is that we get the conjugated base and acid, which is right here. So it's going to be B equals 0.3 molars and A equals 0.3 molar, which converted to moles is just going to be the same, which is 0.3 moles for both. 0.3 moles. But then it tells us that and then 1.1 mole right here, it's 0.10 moles of HNO3 are added to the solution. So if 0.10 moles of HNO3 are added to the solution, the way you're gonna do this is that you add 0.10 moles to the acid and you subtract 0.10 moles from the conjugated base. So it's basically gonna be like this: minus 1 mole minus 1 mole. Okay, so once you add and subtract the mole from once you subtract the HNO3 from the conjugated base, it's gonna equal to 0.2, and then the acid will be equal to 0.4 because you added the HNO3 to it. You always add the HNO3 to the acid and subtract the HNO3 from the base. That's always how it's gonna work. So now it also gives us a pKa, which is 8 right here. So giving to us is the conjugated base, the acid, and the pKa. So the formula that we need to use in order to solve this is the pH equals pKa plus log of conjugated base over acid. So since we already have all the units we need for the formula, all we have to do is just plug it in. So it's just going to be pH equals pKa, which is this right here, which is 8, plus the log of the conjugated base, which is 0.2, divided by the acid, which is 0.4. So once you do the log of 0.2 divided by 0.4, you just need to add the 8 kPa, which then will give you your pH. So in this case, your pH will equal, if you round it up, it's going to be 7.7. That's how you get the resulting pH for this question. Thank you.